Picture it, a learner sitting completely alone at a table. The laptop is open, a glowing screen, and everywhere they look, there's just this blinding wall of AI headlines. Machine learning, neural networks, autonomous agents, prompt engineering. It's a lot, right? The sheer volume of it is completely paralyzing. So they just gently close the laptop. Defeated by the fog of it all, it's a really familiar silence. But, what if the problem here isn't intelligence? What if nobody actually taught us how to enter difficult subjects? Why do incredibly smart people quit learning just a bit too early? Well, the answer is actually pretty simple. It's because we're so often told to memorize things we haven't even understood yet.
So, welcome to this explainer. And I want to make a promise right up front. We are not going to look at a single piece of complicated code today. Not one. Instead, we're going on a deeply human journey. Think of this explainer as a connected staircase of understanding. We are going to take all those heavy, terrifying words and transform them into a solid path you can actually walk on. We'll go from the human mind to the machine and then right back to human judgment. And as you'll see, an ordinary human is entirely capable of learning some pretty extraordinary technology.
Here's the map for our staircase. We'll start with mind before machine, then data before datasets. Next up, the model before magic, learning through honest error, agents before autonomy, and finally, human review before trust. By following this map, I promise you, you're never going to feel lost. We're moving straight from confusion to absolute clarity. Let's take that first step.
Step 1, mind before the machine. It's all about building the mind first. Why do technical words feel so incredibly intimidating? Well, a machine can calculate at lightning speed, sure, but speed is not understanding, is it? Before a machine even begins to spit out an answer, the human mind needs a reliable way to just meet the difficulty. Learning doesn't actually begin with a computer. It begins with the human body. Think about this inside-out engine. A child, or an adult for that matter, literally cannot reason well when they're flooded with panic. Panic is the absolute enemy of intelligence. This engine shows us that learning actually starts with a calm body. You have to notice the facts and regulate those internal triggers before you can even begin to test any patterns. You just have to be calm enough to see, curious enough to test, and brave enough to try again. Now, when we inevitably hit a really dense, technical sentence, we enter what I like to call the fog. And what do panicked minds do? They try to memorize the fog. It doesn't work. A wise learner, though, uses a compass. When you feel confused, treat that confusion as a location, not a verdict on your intelligence. Start logging your fog points. Find the exact word that tripped you up, because a mist that is named is already becoming weather. It's something you can handle. And to clear that fog completely, we use something called the 4 handles. Listen, no piece of jargon should ever be allowed into your mind until it passes through these 4 specific gates. First, what is its plain meaning? Second, give me an everyday example. Third, what is its specific use? And fourth, and this is absolutely crucial, what is its honest limit? When you start putting handles on these heavy, scary words, they stop being walls. They literally become doors. Moving up the stairs, Section 2, data before datasets. Let's talk about observation with a real purpose. Have you ever wondered how ordinary noticing turns into scientific evidence? We hear a word like dataset, and we instantly imagine this locked, sterile, high-tech laboratory. But let's break that illusion right now. Data is not born inside software. Software comes way after careful human noticing. It all starts with attention. You notice the world. You give in meaning a consistent name. You record one single event, and boom, that becomes a row. Then you record the properties of that event, and those become your columns. Just like that, the super intimidating word dataset is revealed to be nothing more than a disciplined collection of human observations. Let's look at a totally everyday example. Imagine Omar, a local shop owner. He's writing down his mango sales, the rain outside, the size of the crowd, maybe some late deliveries, all in this messy little notebook. Well, a row is just one day. The columns? Sales, weather, waste. Omar already has a data set. You see, data really begins the moment observations are organized with purpose. It is, at its core, a human act of witnessing the world. Step 3 on our staircase, the model before magic, how we go from a pattern to a prediction. So once we actually have our observations, how does a pattern become a prediction? And why is it absolutely essential that we never, ever treat AI models like they're magic? I mean, we constantly hear these stories about AI making just bizarre errors, right? Well, why do models make mistakes? It's simple. Because the world is full of noise, missing factors, and wild, unpredictable variation. These model errors aren't failures, they are vital clues. They're telling us that reality is infinitely more complex than whatever mathematical formula is trying to summarize it. This brings us to a quote from our source material that perfectly captures this idea. When footprints curve, do not accuse the road of disobedience. Think about that. If reality, the road, deviates from your prediction, the footprint, you don't blame the data. You certainly don't blame reality. You adjust your understanding. And that leads us straight to the ultimate definition of what a model actually is. A model is merely a disciplined guess built from clues. That's it. It is not the absolute truth, it's just a simplified representation, and it has to be tested. When we finally strip away the illusion of magic, we're just left with a tool. And like any tool, it requires our humble, constant review. All right, moving up to step 4, learning through honest error. This is where we try, fail, learn, and repair. Let me ask you something. Why does confusion contain such useful information? In machine learning, the gap between a prediction and reality is called a residual. It's essentially an error. But in our own human learning, how do we treat our errors? Well, we use a mistake book. Now, this is not a place to write down your shame. It's a workshop for your mind. You just track what you predicted, what reality actually turned out to be, why that gap matters, the consequence, and finally, the repair. A miss just becomes a testable repair. The error rings a bell, not to shame the assembly line, but to wake up the learner who maybe stopped listening for a second. You really have to notice the difference between punishment and learning here. When we make a mistake, we almost always launch an identity attack on ourselves. Oh, I am careless, I'm just bad at math. But a mistake is not proof that you're fundamentally broken. Instead, look at the factual evidence. I submitted the file without checking the numbers. You see, a person cannot repair a vague identity attack, but they can absolutely repair a specific behavior. Clean evidence beats shame every single time.
Okay, let's step up to the next level. Section 5, agents before autonomy. We need to build a loop first.
So we've talked about data, we've talked about models, but what actually happens when our tools start making choices for us? What happens when a model becomes an agent? Well, before we grant any system freedom, we have to define the boundary. A tool is really just a named capability. It's a reach. But every single reach needs a boundary, a limit that keeps it from acting carelessly. An AI agent is simply a system that coordinates multiple tools. But the golden rule is this: it must ask for permission before it exercises real power. Just take a look at this workflow for a second. A tool searches for a result. Another tool takes a note based on that. Another one drafts a message. But look right there, at that critical 4th step. Human approval. A strong workflow passes meaning, not just automated tasks. There absolutely must be a pause, a review gate, before any automated system takes a real-world action that affects actual human beings. Which brings us to our final step, Section 6, human review before trust, that essential pause before action. We have climbed all the way from the calm mind through data, models, and tools, and now we arrive at the biggest question of all. With all this incredible hype around total autonomy, why do AI agents still need human review? Why can't we just kick back and let the machines run the whole show? Because, as our sources so wisely remind us, a powerful model can still fail in human ways. You have to remember, AI is just an extension of human logic. It trains on our human data, which means it carries our human gaps and our human errors. Having a human in the loop is not just some temporary fix until the tech gets better, it is a non-negotiable feature of responsible technology. The system, as we've said, is not magic. So before we adopt any shiny new AI tool, we have to pass it through what we call the risk gate. We must ask ourselves these 6 critical questions. What is the actual goal? What is the true cost? What is the worst realistic downside? Do we have a buffer? Who is actually affected by this? And what is our repair plan if things go wrong? Because a person who can calmly answer these questions is someone who will never confuse technological excitement with actual readiness. And there it is. We have officially reached the top of the staircase. You now hold the compass. You understand that a model is just a disciplined guess, that data is just human noticing, and an agent is just a tool that desperately needs a boundary. You see, the future does not ask for our panic. It asks for our return. One page, one practice, one repair at a time. A door only opens by being used. So I'll leave you with this. What small, honest question will you ask tomorrow to open your next door?